Hello, my name is Erin Cox, and I'm a physiotherapist. We're going to look at the biomechanics and anatomy of flexion of the wrist. So first of all, we have the radius and ulna, and then the proximal row of the carpal bones, which is in a convexity, just like this. If we go from the proximal row to distal row, if we look at the capitate, which is convex Big Daddy all the way around, but the capitate and the hamate are also like a convexity on the concave surface of the lunate and the triquetrium. But if we go to the radial side, it's the opposite. So the trapezium and the trapezoid are concave on convex, which will make a difference in our biomechanics. If we're going to go into flexion, the proximal row will move dorsally. But what will happen in the next row, if the capitate and the hamate are convex, they will also move dorsally when we go into flexion. But the trapezium and the trapezoid, because they are concave on convex, when we go into flexion, they will move in a palmar direction. Just to note, also with flexion goes folding of the hand, in which case, like we said, around Big Daddy, what will happen is the scaphoid and the trapezoid will do a palmar glide, and then the lunate and the hamate around the capitate will also do a palmar glide to help us with the folding and flexion of the hand. So if we take the hand and we want to do a flexion, there will be a dorsal glide of the proximal row, but then we're going to have to do a dorsal glide of the capitate, a dorsal glide of the hamate, but as we come to the radial side, we're going to do a palmar glide to help flexion of both the trapezoid and the trapezium. And for our folding, we said we have the capitate. We will do a palmar glide of the scaphoid and of the trapezoid, and a palmar glide of the lunate and the hamate to do our folding, which can also help with flexion. Thank you.